Have you ever found yourself stuck trying to use a function in C++ that just doesn't seem to work the way you expect? It can be really frustrating, right? If that's you, then you're in the right place. Today, we're diving into a common issue with using std_min as an algorithm parameter. I totally get it. You want to replace every element in a vector with the minimum of whatever came before it, but the standard library isn't cooperating. You're not alone in this struggle. Many developers face similar challenges when working with overloaded functions. Here's the specific situation we're looking at. One user recently asked, how can I use std_min as a parameter for partial sum? They found that std_min is overloaded, which complicates things. Sound familiar? Let's explore this together and find a solution. So, what's the issue here? The problem arises because std_min has multiple overloads, and the partial sum template can't be instantiated with an unknown type. This can lead to confusion and frustration when you're trying to implement a straightforward solution. And stick around. I have a neat workaround at the end that will help you implement this without reinventing the wheel. To address the user's first question, we can create a custom functor that will allow us to use the minimum operation with the standard library's algorithms. This functor will define an operator that takes two integers and returns the smaller one. Next, the user can utilize this functor with the std partial sum function. By passing the custom functor as the binary operation, we can achieve the desired result of replacing each element with the minimum of the previous elements. Now, let's discuss the second question regarding the introduction of the initializer list overload in C++11. The user is correct. This change did affect how std_min can be used in certain contexts, particularly with templates. In conclusion, the user can solve their problem by implementing a simple functor and using it with a std partial sum. This approach avoids the need for complex constructs and adheres to the standard library's design. Fun fact, did you know that C++11 introduced initializer lists, which changed how we handle certain functions? It's amazing how a small change can have such a big impact on our code. Now, let's look at the answers provided by other users. One alternative solution provided by a user is to add a const modifier when using std_min. They suggest defining a pointer to the min function like this: constant in, constant on, and constant equals std_min in. This approach can help resolve compilation issues. Here's the workaround I promised. By creating a functor, you can avoid the pitfalls of overloaded functions and keep your code clean and efficient. And there you have it. You've learned how to use std_min effectively with std partial sum. Remember, understanding the tools at your disposal can make all the difference. If you found this helpful, hit that subscribe button for more coding tips and tricks.